So we're on section 1.5. It's called segment and angle measure. Today we're just going to talk about the segment part. Okay, we won't have time to get to the angle, but we're going to do the segment measure today. All right, and then on Monday we'll do the angle measure. So let's talk about that. Here's a word that we're going to be using quite a bit, and you guys took Algebra 1 last year, right?
Yeah.
Do you guys remember doing like that X and Y axis, and you did the slope and rise over run and all that stuff? Okay.
Yeah.
So you've probably heard this word before. Okay, we call them coordinates. Do you remember that? So when you do that rise over run and y equals mx plus b, do you remember y equals mx plus b and all that? So that's called coordinate geometry. But we're just got to talk about that word. And we have a whole section somewhere in the book. I forget where it is exactly, but it's called coordinate geometry. Today we're just going to talk about the word coordinate, all right? And it's basically, I didn't write the definition down in my notes the way I should have, so I'm going to read it from the book. It says the coordinate is on a number line is the number that corresponds to the point. So we got a number line. So we really haven't talked about numbers yet in here. So, but you've had experience with this, okay? There's a number line. Let's just center that up a little bit. All right, here's a number line. So remember this? You had these little dashes through here. Supposed to be evenly spaced. That kind of messed it up a little bit. I don't know. Let's just start with, I don't know, -4, -2, -1, 0, 1, 2. All right? So there's a number line. But what if you put some, what did I do? I sure did, didn't I? Math teacher can't count. -3, -2, -1, 0, 1. Let's put one more in here. Put a 2. Okay. Oh, what? That's all right. I don't need all that. So what if we did this? Watch. What if I said that's point A? If I said that's point B, and this is point C, right there. Okay. So what value is associated with point A on this number line? What's at point A? Okay, -2, right? So we say that -2 is the coordinate of point A. You hear what I just said? It's where it's located. Coordinate means where it's located. I don't know if you've ever watched old movies or not, but there's old movies, maybe, you know, it's a war movie or something, and the guy's in the back of the plane. Maybe it's like World War II, right? And the guy's back, and he's navigating, and the pilot's like, give me the coordinates. What are the coordinates? Anybody ever hear that before? Okay, yeah. What are my coordinates? The coordinates means where is my location? Where am I located? And that's basically what coordinate means. It's the location of a point. So what is the location? If I put a point right here, what is the location of point A? It's a -2, exactly right. And then the rest is easy. What's the location of point B? 0. What's the location of point C? 1. So instead of saying what is the location of, what do we say? What is the coordinate of point A? And you would say -2. Does that make sense? Yeah, it's pretty easy. It's kind of a fancy word, but it's pretty simple in what it means. All right? So we got to know that stuff first before we move on to the other stuff. So let's do another vocab word. The length of a segment. All right? So we know what a segment is. A segment doesn't keep on going in both directions. What's a segment do? Starts and stops. Okay? Starts and stops. And so we can measure it. Remember we talked yesterday about that? A segment is something that we can measure. And that's kind of what we're going to do here. We're not going to take a ruler out because I know where the coordinates are, so I should be able to use those numbers, right? Like if you looked at a tape measure or a yardstick or a meter stick or something, you got those little lines on there and it tells you, right, how far things are. So if I was to use it to measure something, you would say, oh, you put it up against here, it's from here to here, it's that far. And you basically, you just count. The length of a segment. So let's do this. Let's do a different number line. Let's do a different number line. I'll say this is -2. Let's go up to 3. -1, 0, 1, 2, 3. All right. What's going on over there? All right, and then we'll call this point A on this number line, and we'll call this point B. So what I want to do is I want to find the length of the segment. So if I said segment AB, do you see segment AB? Starts here, stops here. If I asked you to find out how long it was, the length of it, the measure of it, what would you do? Doesn't have to be in the middle. I mean, it's between -1 and 1. It has to do that. But it doesn't have to be in the middle of the number line. So what's the length of it? If you start at A and you walk to B, how far have you walked? Let's say it's in meters. Make it easy. 4 meters. That's right. How did you do that? Just count. That's right. You just count. Watch. 1, 2, 3, 4. It's easy. But what if point A was at like -279 and B was at 3,482? That would be crazy to have to count all that, wouldn't it? So we need a better way. We need a better way than just counting how many points. So we said it's 4, right? If I walk from A to B, that would be 4 meters or whatever it is, miles, whatever you want to make it. So what's another way to do that instead of just counting? That's right. Subtract it. Exactly right. All right. Let's go easier. What if I wanted to go from 1 to 3? How far is it to go from the 1 mile marker to the 3 mile marker? It's 2 miles, right? So I could just count, or I could do what to those numbers, that 1 and 3? Just subtract them. Does it matter what order we subtract them in?
Yes.
Okay, so let's do the 1 and the 3. That's before we get to that. Is that all right? So let's just make that a C. All right. So let's find the length of CB. I could just count 1, 2, or I could do some math on it. Let's subtract. I could go 3 minus 1. How much is 3 minus 1? It's 2. All right, so that's the same thing, isn't it? If I just subtract. What's another way I could subtract it, though? I could go 1 minus 3. A lot of you guys said you can't subtract it like this. There's only one way to subtract it. Yeah, what's 1 minus 3? It's -2. Good. Is 2 and -2 the same thing? No, it's not. But listen carefully. When we measure things, like I measure the length of this room, I don't say, well, it's -20 feet, right? Would I ever say that? No, I just say it's 20 feet. It doesn't matter if I start over there at that wall and measure to this wall, or if I start from this wall and measure to that wall. Does it matter which direction that I measure from, where I put the end of the tape measure? It doesn't make any difference, okay? So that negative basically just tells me which direction that I'm measuring. But that doesn't matter, right? Because it's still 20 feet. Doesn't matter which way you started. So what they do is this. Now this looks a little weird, but you've seen this before. Are you kidding me? Oh, why did it do that? My marker's not working now. Oh, there it goes. Whew. I hope it works. All right, so watch. What they're going to do is this. I want just a 2. Add a 2 and -2. So now watch very carefully. Don't freak out. Okay, I put these things. What does that mean? You've seen that before. It's absolute value. Exactly right. And what does absolute value do for you? Well, it changes one thing, but it doesn't change the other. It does tell you how far away from 0 it is. That's good. It's always positive. Right. That's what I'm... But both of you are exactly right. That's right. I like what Evan said, and I like what Neil said. They said two different things. That's what I'm trying to... That's what I'm trying to do right now. So Evan said it's how far that number is away from 0. All right? And that's a good way of thinking it. How far? Again, we measure things in positive numbers, okay? We don't say, oh, it's -3 meters away. It's just 3 meters away, okay? So that's good. And Neil said, anytime you do absolute value, it just always makes it positive. So if it starts off positive, it's just going to stay positive, right? If it starts off negative, what's the absolute value do? Turns it positive. So every absolute value is always going to give you a positive number. So what's the absolute value of +2? +2, right. What's the absolute value of -2? It's +2. So by putting the absolute value there, that guarantees that your answer is always positive. Does that make sense? So that's why they put the absolute value there. So here's one more thing before we get a little bit more into it. When we talk about the length of a segment, now if I just said segment AB, if all I did was say, let's do this, the length of segment AB. Remember the line segment symbol? It's just a line over top and no arrows. We did that in section 1.4. Remember that? Yeah. But instead of using that word, the length of segment AB, what we're going to do is this. We're just going to put the AB next to each other with no symbol at all. So when you see two capital letters next to each other and no line over top of it at all, right? It's not a line, it's not a ray, it's not a line segment. It's just the length of that line, okay? That's what it means. It's a subtle difference, but it's a difference, okay? It means the length of line segment AB. So if that's all you see, if they said find AB, all right, what does that mean? It's not just AB, it's the what? It's the what? It's the length of, right. It's the length of line segment AB, okay? And that saves you writing all this, okay? Everybody with me on that? That's something a lot of students forget. As we go on, they just kind of forget it. So when you, because people say, what are they asking for, Mr. Hammer? It's just got an A and a B next to each other. Is it asking just for the 2 points, one at A, one at B? No. It's asking for the distance or the length of line segment AB, all right? So we could just count, couldn't we? So let's do this. Let's do this problem right here. Find the length of line segment AB. So we could just count. 1, 2, 3, 4. That's one way of doing it. But again, what if they were real big numbers and it would take too long to count? What would we do? We do some subtraction. And does it matter which order we subtract? Doesn't matter. As long as we do what at the end? Absolute value to keep it positive. Okay? So let's do it both ways just to show you. All right, so A and B. So what are my endpoints? -1, and then we subtract a 3 from it. And remember, it's in absolute value. What's -1 minus 3? Do you remember how to do that? Add a line, change a sign. Remember that? -4. So it's -4. But it's in what? Absolute value. And why is it in absolute value? Because we always want our answer to be positive. So what's the absolute value of A, or what's the length of line segment AB? It's 4. Okay? We could do it the other way. We don't always have to go the first one minus the last one. We could go the last one minus the first one. It won't make any difference because the only thing that will be different is if it comes out negative or positive. But we're going to make it positive anyway, right? So it doesn't make any difference. But let's do it. 3 minus, is it 3 minus 1 to find the line segment AB, the length of it? No, it's 3 minus what? -1. It's a big difference. Now, how do you do that? What's minus a minus? It's a plus, right? And what's 3 plus 1?
4.
It's 4. It's in absolute value. So what's the absolute value of positive 4? It's 4. So if I said find AB, and that's all it said, that means you're going to have a number line. You'll have numbers on there, okay? And you've got to find the coordinates, subtract the 2 coordinates from each other, and you're finding the length of that line segment, okay? Again, it's a subtle difference whether you use line segment AB or AB with nothing over top of it. Like if I didn't have any numbers here, finding the length of AB would be impossible, right? If it wasn't on a number line, so if it was just, let's just slide it in right there. If it was just right here and I said that's A and that's B, and if I said find AB, and this is the only picture that I gave you right there, could you find AB? No, because what is this asking for? The length of it. I don't know the length of it. There's no way I can find it because I don't know what any of the values are. I don't know the coordinates. Okay? So I wouldn't be able to do it. I just wouldn't be able to do it. I wouldn't give you that question. But I'm just saying if you saw something, like that, you wouldn't be able to find the length of AB. We good? Okay. All right. Let's move on. We're almost done. So let's talk about this word. This is a word. It might be the first time you've heard this word. May not be, but it might be. but it's not going to be the last for sure. We're going to talk about this throughout the whole book. This is, I mean, if I could just think of one word that is the most common word out of a whole entire geometry book, it would be the word that we're going to do right now. Okay? And that is the word congruent. Have you heard that word before? That's all right, because it's not really a word that you would use in algebra or pre-algebra or anything like that. Okay, but in geometry, it's huge. All right, let me show you what it is. So here's a line segment. I'm not going to put dots at the end, but it starts and stops. Okay, there's no arrows, so it starts and stops. Watch what I'm going to do. On this little program, I can copy and paste. So I copied and pasted, and all I'm doing right now is I'm just changing the direction of it like that. Tell me something about the length of both of those line segments if I copied and pasted it. They're the same. They're equal to each other, right? Okay, but in geometry, when we talk about line segments that are the same, we use the word congruent, and we don't use the word equal. I don't say that line segment, we'll call it, I really got to think of better letters to use than AB all the time, but it's the first thing that comes to mind. A, B, and YZ.
X, Y, Z. Yeah.
Well, we'll use YZ since there's 2 points. Okay? So I wouldn't do this. I wouldn't say that AB is equal to YZ. Why not? Because what does AB with no thing over top of it mean? What does that mean? It means we're doing what? We just finished going over it. The what? The length. Good. Very good. That's the length of the line. And there's no coordinates. That's right. So do I know the length of this line? No, I don't. Okay? But here's something. It's a little different. Everybody watch. Get rid of that. So you can't really say that just right now. This is what they do in geometry a lot. They'll put a little mark right here and a little mark right there. Both of these little line segments have one little mark. We call that a tick mark. I think it's T-I-C-K. We call it a tick mark. That little mark right there means that they are congruent to each other. That means that if I took one segment, took the other one, flipped it around so they fit right on top of each other, they would be exactly the same. That's what that little tick mark means. It means that they are what? Congruent. Good. Okay? So that little mark, you'll see that a ton all throughout the rest of the year. You're going to see that. We do that with line segments. We do that with angles. We do it inside of triangles and different things like that. We use that tick mark a lot. So if you see a little tick mark here and here, that means that this segment is congruent to this, even though we don't know how long it is. Like, I don't know if it's like 5 inches, 7.32 inches. I have no idea, okay, because there's no coordinates here. So I can't figure out how long they are, okay, but I do know that they are the same, all right, because they have one tick mark here and one tick mark here. Okay. What if I did this? What if? All right, that one's a little shorter. Agreed. And let's just twist it just to show you it doesn't have to be the same way. Now watch this. Now would I do this? Would I put one tick mark here and one tick mark there? Look, I got 4 pictures here. I got 4 line segments. That would be confusing because it's like which ones are equal, or which are, I should say congruent. Which ones are congruent to each other?
The 2 bottom ones are
They ain't labeled.
They're not labeled. You're right. So let's call it PR and, I don't know,
Okay.
ST.
Okay.
All right, we'll use that. So what about PR and ST? Now, I did copy and paste them, so they are congruent to each other, but I can't just put one tick mark, one here, and one here, because that would mean all 4 of them would be equal. How do I show that just PR and ST are equal to each other? Or congruent. I keep saying equal. I should say congruent. How would I show that PR and ST are equal? I just said it again. Congruent. Congruent. I got to keep saying it. I could, wait a minute. I could put another one there. Okay, so now look at this. If you looked at this situation, you should be able to tell which ones are congruent. So which ones are congruent? AB and what?
YZ.
YZ. And what are the other 2 things that are congruent? PR and ST. Is PR congruent to AB? No, because AB's got 1 mark and PR's got 2. Yeah, here.
Wait, what if they're not the same length, they're not congruent?
That's correct. If they're not the same length, like AB and PR, they're not congruent.
Even if they both have 1?
If they both have 1, that means that they are congruent.
So it's only congruent based on the tick?
That's right. Okay, it's the only way we can know. Now, if it was a number line, right, and I gave you the coordinates, and like you figured out that the lengths were the same, then you could say those line segments were congruent. You hear what I just said? I think I said that kind of fast. If it was on a number line and you know the coordinates of those points and you subtracted and you're like, oh yeah, that one's 5 and that one's 5, then you could say that they're congruent. But I don't have any coordinates on this, do I? All right, I don't know any numbers. I can't figure it out. So the only way that we know if those are congruent to each other is by putting those little tick marks there. And the book will do that. The book will mark certain things, congruent. You don't have to take a ruler and measure it and see if they're the same length. They'll tell you. And how do they tell you? They'll tell you like this. One more thing and we'll be done. This word congruent has a symbol. All right? So you already said which ones were congruent. You said line segment AB and what?
YZ.
And line segment YZ are congruent. Let me show you the symbol for congruent. So line segment AB. Now we're not talking about the length of it because I don't know the length of it, right? Length indicates a number. Do I know the number of AB? No, I don't know if it's 5 inches. I don't know if it's 7 feet. I don't know. So I write line segment, okay, is congruent to line segment what? YZ. Now here it is. It starts off being equal, but we don't write equal. Congruent is slightly different. We put a little squiggly thing on the top. So the combination of the equal sign and the squiggle, that means what? Congruent. All right? And again, it's a subtle difference between line segments being equal to each other and being congruent to each other. Okay, equal means you know the numbers, right? You know that's 5 inches, that's 5 inches. All right? Congruent means, oh, that's got a tick mark, that's got 1 tick mark, so they must be the same. Okay? Again, a very subtle difference, but that's what it means. So that's what that means. I'll give you 10 seconds. Write down the congruency statement. That's what they say in the book. Write the congruency statement for the other 2 congruent segments. So write the other 2 congruent segments down. It should take you 5 seconds. Did you write it? So what's the first segment? PR. Put the little line segment over top of it, and it's congruent to, so it's an equal with a squiggle on the top. What's line segment PR congruent to? Line segment ST. Okay, we don't just say ST, we say line segment ST. Because we don't want to be confused between line ST, ray ST, or anything like that, okay? So we say line ST. What if I said PR is 5 and ST is 5? Then I could say, well, watch. It's a subtle difference, but watch very carefully. This will be the last thing. So now I could say that PR is equal to ST. What's the difference? Say it again. No, there's no squiggle on this. Or a line on top. I wrote it like this on purpose. Why is this different than this? Because what is the...
That'll be the length of it.
Exactly right. Well, we do now because I said it was 5. Okay? So if I said this is 5 and this is 5, now I can write this because now I know the lengths. Okay? If I didn't, no, you don't need the squiggle for the lengths because 5 equals 5, I don't put the squiggle on there. I just say they're equal. Okay? So if I know the numbers, if I know the value, if I know how long that line segment is, then I could do this. Okay? But if I just have the tick marks, this is how I write it. I know it's a little confusing, but the more we do it, the more I explain it to you, you'll get it and understand. Okay? All right, that's it. We'll finish up segments probably Monday. I don't even know if we'll get to the angles on Monday. We might, but we are taking a quiz on Monday. Okay? Remember, 1, 2, 1, 3, 1, 4. Quiz on Monday.